You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Multitenancy refers to the architectural approach where multiple customers, known as tenants, share the same physical infrastructure within a cloud environment. Each tenant operates in an isolated context, even though they occupy the same physical servers, networks, and storage devices. The goal of multi-tenancy is to provide efficient use of hardware resources while preserving the functional and security boundaries between tenant environments. This structure is most common in public and hybrid cloud scenarios, where logical separation replaces physical segregation. Cloud systems use logical boundaries to separate tenants, ensuring that each tenant's data, services, and configurations remain inaccessible to others unless explicitly authorized. These boundaries are enforced through software-defined controls that operate at multiple levels of the stack, from hypervisors to API layers. The Cloud Plus exam includes questions that evaluate your ability to identify whether proper isolation exists, how isolation is enforced, and what happens when isolation boundaries are misconfigured. Multi-tenancy appears frequently in Cloud Plus questions that focus on security, system performance, or service delivery. Because multiple organizations may share the same physical server or storage system, isolation becomes critical to prevent data exposure, privilege escalation, or resource conflicts. Scenario-based questions may describe shared environments and require you to determine whether isolation controls are sufficient or whether system behavior violates expected design principles. Cloud Plus distinguishes between physical and logical isolation as part of understanding multi-tenant design. Physical isolation means each tenant is assigned their own hardware, with no shared physical components. This approach provides stronger separation but is costlier and less scalable. Logical isolation uses shared hardware but creates independent execution environments through virtualization, identity segmentation, and access control. Candidates must recognize which approach is being described and what implications it has for security and design trade-offs. In most cloud environments, compute, storage, and network components are shared among tenants. The shared resource model relies on abstraction layers to maintain tenant separation. Hypervisors separate virtual machines, software-defined networks, segment traffic, and access controls prevent unauthorized data queries. Understanding how these systems collaborate to isolate usage is critical for interpreting exam questions about resource contention, performance degradation, or security lapses. Infrastructure components in multi-tenant systems must be tenant-aware. This means they can identify, isolate, and manage requests based on tenant context. Cloud platforms accomplish this using identifiers such as tenant IDs, namespaces, or container scopes. These identifiers are tied to platform services, subscription accounts, or project metadata. Tenant awareness ensures that operations such as billing, provisioning, and security enforcement are executed without overlap or leakage between organizations sharing infrastructure. The hypervisor plays a critical role in separating tenant workloads by allocating virtual CPUs, memory, and storage within defined boundaries. Container engines provide additional segmentation at the process level, isolating application environments through cgroups and namespaces. These technologies enforce logical boundaries while allowing resource sharing. Cloud Plus questions may describe environments where these boundaries have failed or been misconfigured and ask how isolation can be restored or strengthened. Security is a core concern in multi-tenant architectures. Improperly implemented isolation controls can lead to unauthorized access, data leakage, or malicious tenant activity. Attack surfaces increase when shared systems lack strong tenant separation at the control plane or data layer. The exam may present scenarios in which identity boundaries are breached or encryption is applied inconsistently. Candidates must understand how to enforce secure separation through IAM policies, encryption scopes, and data tagging. Cloud storage in multi-tenant environments relies on logical partitions to assign data to specific tenants. Each partition is linked to a tenant ID and is protected by access control lists, encryption keys, and usage policies. A common exam scenario involves a misconfiguration where one tenant can access another tenant's files. Recognizing the correct access policy to apply or identifying the isolation control that failed is an essential exam skill within Domain 1. Multi-tenant systems must address the challenge of resource contention. When multiple tenants draw on shared resources like CPU, memory, or network bandwidth, system performance can degrade. Cloud platforms use scheduling algorithms and quota systems to allocate resources fairly. Cloud Plus may test awareness of mechanisms such as fair share schedulers, resource limits, or burst allowances. Candidates should know how these tools maintain performance balance without favoring one tenant over another. Virtualization enables multi-tenancy by abstracting physical hardware and creating independent execution contexts. Hypervisors assign virtual machines to tenants, each operating with its own OS and resource scope. Containers add a further layer of abstraction, enabling lightweight, isolated application environments within shared hosts. Virtualization technologies are essential to the functioning of multi-tenant systems. The exam often references these technologies in the context of tenant isolation and infrastructure segmentation. Tenant lifecycle management involves provisioning, managing, and retiring tenant environments. New tenants are onboarded using account creation, subscription binding, and access policy assignment. During their lifecycle, tenants consume resources, trigger monitoring events, and generate billing activity. When tenants are deprovisioned, all associated resources and permissions must be revoked. Cloud Plus scenarios may include references to expired tenants, inactive accounts, or dangling resource entitlements, requiring candidates to identify cleanup procedures. Cross-tenant communication is intentionally restricted in multi-tenant environments. Services are designed with defaults that block any interaction between tenant resources unless explicitly configured. Shared services, if required, must be segmented or proxied to avoid data exposure. Misconfigurations can allow unauthorized access between tenants, violating isolation policies. Exam questions frequently use cross-tenant communication as a red flag, asking candidates to identify and correct flawed network or service designs. Identity and access management is a primary mechanism for enforcing tenant separation in cloud environments. Each tenant typically maintains its own users, roles, and access policies, which must remain confined to that tenant's scope. Identity boundaries are enforced through role-based access control, often combined with attribute-based conditions to apply fine-grained rules. In multi-tenant systems, IAM misconfigurations can result in unintended access to resources outside of a tenant's domain. Cloud Plus questions may present these scenarios and require candidates to identify the access control failure. IAM design must account for user roles both within a tenant and across the entire system. Tenants may have administrators, developers, and read-only users, each requiring scoped permissions that do not affect other tenants. Exam items may include scenarios where a role inheritance causes unintended privilege elevation. Candidates should understand the difference between shared platform roles and tenant-scoped roles, and be able to identify when boundary enforcement has been improperly applied or omitted entirely. Monitoring tools in multi-tenant systems must segment data collection and presentation by tenant. Performance metrics, usage statistics, and security logs should be tagged or filtered so that each tenant only sees information relevant to their own environment. Shared dashboards must be designed to prevent data exposure across tenants. On the Cloud Plus exam, scenarios may describe metrics being misrouted or logs showing information about other tenants. Identifying the misconfiguration and applying proper scoping to monitoring output is a key skill. Resource quotas are necessary to ensure fairness in multi-tenant environments. These quotas define the maximum compute, storage, or network resources a tenant can consume within a given time frame. Quotas protect shared infrastructure from being overwhelmed by a single tenant's usage spikes or unbounded growth. Cloud Plus questions may describe performance degradation or unexpected billing spikes and ask the candidate to identify that missing or incorrectly configured quotas are the root cause of the issue. Tools used to manage multi-tenant environments must support tenant tagging, scoping, and segregation features. These tools often include orchestration platforms, API gateways, and administrative consoles with multi-tenant awareness. Systems must assign tenant identifiers to all resources and enforce policies that prevent unauthorized cross-tenant manipulation. Cloud Plus scenarios may describe a resource management platform lacking tenant context or failing to enforce isolation, prompting the candidate to recommend updated tooling or controls. Multi-tenancy is foundational to software as a service and platform as a service models. In SaaS, a single application instance often serves multiple organizations, with tenant data separated logically. In PaaS, tenants may deploy their own applications into a shared infrastructure, requiring isolated runtime environments and namespace management. The exam may include questions about tenant separation and application design, deployment boundaries, or data partitioning strategies within shared backend systems. Debugging issues in multi-tenant environments poses unique challenges. Support teams must trace incidents or errors to specific tenants without exposing log entries or system behavior related to others. This requires scoped log access, tenant-aware tracing tools, and audit trails that isolate each user environment. Cloud Plus scenarios may present ambiguous error conditions or shared logs and ask how the support process should isolate the issue without compromising tenant privacy or visibility. Tenant metadata plays a critical role in managing resources, enforcing policy, and maintaining traceability. Metadata may include organizational identifiers, billing tags, compliance indicators, or environment classifications. These tags help drive automation, generate reports, and enforce constraints. In the Cloud Plus exam, questions may reference metadata used in policy engines or auditing systems. Candidates must recognize how tenant tagging influences provisioning, policy enforcement, and deprovisioning workflows. Audit and compliance requirements often mandate that logs and records be tenant-specific. Data retention schedules, access trails, and security events must be attributable to individual tenants. This ensures that investigations, legal discovery, or regulatory checks can be conducted without affecting other customers. Cloud Plus scenarios may include audit failures or incomplete tenant trails, and expect the candidate to recommend proper logging and record scoping strategies to meet compliance expectations. Data residency is another compliance factor influenced by multi-tenancy. Tenants may be subject to legal restrictions regarding where their data can be stored or processed. Cloud providers must ensure that tenant data remains within the required geographic or jurisdictional boundaries. Multi-tenant platforms must apply residency controls at the infrastructure and service layer. The exam may test awareness of location tagging, region-based policies, or segmentation rules tied to regulatory requirements. Tenant deprovisioning must remove all associated data, policies, identities, and resources without affecting other tenants. Incomplete cleanup processes can leave orphaned configurations or residual access rights, potentially exposing systems to risk. Cloud Plus exam scenarios may describe inactive tenants still consuming resources or systems showing references to deleted tenants. Candidates must understand how lifecycle management tools enforce complete and isolated deprovisioning. Service providers must support billing transparency in multi-tenant models. Usage must be tracked and charged per tenant, with clear attribution of resource consumption. Inadequate separation of billing data can lead to disputes or inaccurate invoicing. Cloud Plus exam items may reference billing dashboards or reports that show overlapping usage between tenants and expect candidates to identify misconfigured tagging or usage tracking mechanisms. Multi-tenant architectures require platform-level support for strict segregation across all layers of the cloud stack. This includes compute, storage, networking, monitoring, identity, automation, and billing. Without consistent enforcement of tenant boundaries, cloud systems risk failures in security, privacy, and performance. Questions on the exam will reflect real-world challenges in maintaining these boundaries and will test the candidate's ability to recommend isolation strategies that preserve tenant integrity. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.